Good morning, GIS 300. It is time to get into some terrain analysis, specifically visibility analysis, where the question is, what can you see from here? Or vice versa, from where can you be seen? Now, you may already know from FOR 242 or prior knowledge that you can get the viewshed from a single point in Google Earth. You do that by creating that point, placing it where you want to be, there on the hike towards the knife's edge. Hit OK, right click, and show viewshed. It'll ask you if you want to automatically adjust, so it's 2 meters above the ground, that's where the eye should be, adjust automatically. It'll think about it for a moment, and then once that's done, it'll give us a hopefully correct viewshed, which gives us a pretty decent view there. I mostly believe that. If you see an all green circle here, you have to check on the button for terrain. If you don't have the terrain checked on, of course, it's not going to work at all. So you can allegedly see all of this and all of this. But I can't see the elevation model, I can't see exactly where the highest point is, and I can't show the view along the entire trail. All of those things I want to do. So first of all, we need some LiDAR data. We want to have a LiDAR data set because, one, we have it, that's wonderful, and two, it's going to be the most accurate. And we want to use our LiDAR-derived data set to do this. So search NOAA LiDAR from the coast.noaa.gov NOAA Data Access Viewer, elevation/LiDAR. And then go ahead and zoom in on Katahdin, and you can check on the satellite image there so you can see where you're going. So a little bit low there, and there's Katahdin. Now we're going to evaluate the A-ball slide trail, or whatever has replaced it, or maybe the hunt trail. So we're going to use our draw box, and we're going to click, hold, drag, and release a box that shows about that area. Can't go too big on this because this is a very big data set, almost 1 billion points there. You don't want to go much over 1 billion points, it starts to bog down. So click there, add to cart, and from there, go to the cart and say next. We want the output product to be a raster. We want the grid method to be a spline. I've tested out all the different methods for this location, and this one fills in some gaps that persist with the other methods. And we want to change that grid size to 5. So that's going to be a 5 by 5 meter raster grid, and that's a pretty good balance I'm finding between the precision that can come from LiDAR and computational time. Finally, let's change this to UTM zone 19 north and hit next. Go ahead and give it your email, not mine, and then hit next again, review your order, and submit. And in due time, you'll have an email that looks like this one. This order has been split into a number of different parts. Looks like about 20 different TIFF image files, which we'll have to stitch together. So I'm going to click on that download link, which will take me to a zipped or compressed file, which I'll then have to extract. That's finished downloading now. And here's my zipped folder, which I then have to extract here. I'm going to browse and place that in my GISNT, GIS 300 week number 7, select that folder and extract. Now, normally we would add data in through the browser tab, but here we actually want to stitch them together before bringing them in. Under Raster, Miscellaneous, Merge. We have to select the inputs here, and then I'm going to add directory, and I'm going to go to where I just saved them, which is GIS 300, week number 7. Select that folder. And here is an interesting issue that I've been having, where this is the last thing I did, one of the test runs I did for this. You see how this is the ANUDEM thing? This is sort of held over in its memory, it seems. So I need to clear all that. And let's see if I can add the directory again. See, this is where it was before. It just got a little confused there. So I need to select week number 7, and there is week number 7. So check your file path there. If this is your first time doing it, you shouldn't have this problem, but there you go. So I also want to uncheck these other things that I don't want stitched together. These are other files that I have in the same folder, and this .xml doesn't want to be checked on either. Once I've got the ones I want here, then I hit OK. Now I'm going to scroll down, save to a temporary file, and run. And when that finishes, I end up with this merged together. This is all of the different rasters stitched together into one. And I like this, so I'm going to save it permanently. Right-click, export, save as. And now I see that I made an error here. So sometime while I was exporting this, or telling NOAA Digital Coast what I wanted exported, it switched itself back to 1 by 1 meter resolution. That's fine, it's going to give you a very nice view of this thing. But for you, I recommend 5 by 5. It's going to take a lot less time to process. Or if you have a very fast computer, by all means go with 1 by 1 meter resolution. So this needs a name, and I'm going to plop that in week 7, and I'm going to call that the Viewshed DM. Because that is the elevation model I'm going to use for my viewshed. Okay. That loads there, and now I can right-click, remove that layer, and we're ready. Before we get started, we can do some things like change the min-max value settings to the updated canvas, which means the highest and lowest values are always going to be calculated within this screen, which is good for when you want to see what the highest point is. So I can see pretty well somewhere in here is going to be my high point. But this color ramp isn't the best for that. Let's change that. Double click, instead of single band gray, single band pseudo color, and I'm going to use this default ramp, classify it, but I want to actually invert that color ramp. So there you go. And then I'm going to go to my min-max value settings and set the statistics extent to the updated canvas again. Okay. And I had to zoom in and out once to make that go from all red to display as I want it. And now as I zoom in, I can see which ones within this view are the highest. It's either going to be one of those, and then I can use this Identify Features tool to get the exact values of 5,248, 0.84, 0.64, 0.84, so this is the top point. That's going to be important when you do your viewshed analysis, because if you're not on the highest point, if you're here instead of here, this could block your view when you're really trying to answer the question of what's my view from the top. Now let's make this look a little bit better with a hillshade model. Right-click, duplicate layer, and then double-click, and instead of single band pseudo color, hillshade. Okay. Uncheck that one, check that one on. That's the traditional hillshade. I don't love that for Katahdin, so let's try the multi-directional. Apply that. That's a bit better. I want to change the Z factor to 2. I like that for that kind of a model, and I'm going to change that brightness to try 40. Apply there. 60. Apply there. 80. Apply there. Pretty difficult with this very steep terrain, but let's look at what this looks like with the elevation model on, and we're going to move this over and change the transparency, and we'll set that down to try 65%. That's looking a bit better. Let's try that. That's looking pretty good. So as we zoom around, let's see how that changes. Pretty good, pretty good. That gives a very nice view of the knife's edge, which might be important soon. Next, we're going to open up the Trails network for the state park and see that this does not exactly follow along the exact ridge here. That's going to be a bit of a problem. We can see looking at the air photo that that is a bit off, but the trail up Pomola Peak is pretty well dead on. So you know what I'm going to do? I'm going to digitize my own representation of the knife's edge. And I'll have you do the same, because when you look at this with your 5 meter resolution elevation model, you should follow along the highest points on your trail, which could be slightly different. So what we're going to do, right click on your working folder, new shapefile. Going to call that a geometry type line, and we're going to use UTM zone 19 north. And let's see, we have location, we have a type, we have a coordinate system. Don't need fields yet, so go ahead and hit OK. And now we have a new trail line here. And what did I just call it? New layer. I should have given that a name, but I can rename that here. We'll call that knife's edge. And I'm going to make that a nice bright red. Simple line, a bit thicker, and we'll make that a nice bright red. Okay, okay, good to go. So what I need to do is right-click on knife's edge, toggle editing, and now I can add new features. So this one here, add line feature, click that, and now we're working with that tool. Go ahead and zoom in on where you want the start to be. And I'm going to start from Pomona Peak, and then I'm just going to click along, and I'm just going to connect the high points here. Is that going to be exactly right? Maybe, maybe not, but I think it gives the best representation of the knife's edge trail and what you might expect to see from it. So the end result of all of this is what can you see as you're walking along here, and which of these points has the most visibility. And of course the knife's edge gives you a great view, you know that. Even if you haven't been up there, one look at this, you can tell, well, this is about as high as you can get in the state of Maine, and you have pretty good unobstructed view all the way around. So, we're going, going, going. But of course there's places you can't see. There's a whole mountain in front of you in some places, you can't see what's on the other side. And sometimes there's such precarious going that you're not really even looking around you. You're trying to look for a handhold and not fall to your death. That's what we do for fun, right? Right. Carrying along, carrying along. So every time I click, that adds a vertex. So we're creating points, the line, oh, on off base there, Control Z. Oh, doesn't let me do that, oh well. So we're just gonna go with that. And we'll just call that a happy accident. We're doing GIS Bob Ross now. And forgive you for fast forwarding through this if you do, but we'll get there. So we're getting close to Baxter Peak now, and we'll just keep following this ridge along. Down a little off it there, that's okay. More happy accidents. And we'll end there. Okay, and there it is. So now we can see we have a new trail, or a new representation of that trail, that follows that ridge line of Knife's Ridge exactly. So we can get a quick estimate of the length of this line by just more or less following along there. Total thing about 1,400 meters. Close. Now, we want to create some points, and we have a tool to create points randomly along this line, which is actually not bad from a statistical perspective, because we don't really have any regular interval by which we'll know we'll be looking. So, as we walk along at some random points, we'll turn around and take a look. So let's go ahead under Vector, Research Tools, Random Points on Lines. And we're going to use the knife's edge as an input. We're going to generate 100 points where we'll take a look around us. And we'll say, give us a minimum 10 meters between points, should do. And go ahead and run that. Close. So that looks pretty good. Not perfectly evenly spaced, but randomly enough to be believable as you're walking along, taking this hike. And look, it includes just about the end of Baxter Peak there. So that looks like a reasonable representation of all the times a person might perk their head up, take a look around as they're hiking across the knife's edge. Now we need to install a plugin, and I think we've talked about this before, but QGIS is built around plugins. The language that the program itself is written in is open source, so you can read that language and then speak that language back to it, give it instructions for how to do a specific task. And in this case, that task is visibility analysis. So plugins, manage and install plugins. And let's see what I have installed here. So I have profile tool, I have visibility analysis. I'm going to uninstall that because I need to show you how to install it. So that's gone away. Now I go to all. So all here, search visibility analysis. This one. Click once, install plugin. It'll load what it needs, bring all that in, close, and now that's installed. Over here in your processing toolbox, you have a variety of tools. If you don't have processing toolbox, under View, Panels, Processing Toolbox. And after you've installed this plugin, you'll see Visibility Analysis at the bottom, and you can open that up. And we need to do two things. First is prepare the data under Create Viewpoints. Double-click. Observer locations, the random points on the lines, and the digital elevation model is our Viewshed DEM in this case. That's what I've called my elevation model. And we have the observer IDs, and we want to change that to the random point ID. I'm going to keep the radius of the analysis, and I'm going to keep the observer height as standard defaults there. Keep all the rest, and create a temporary layer. Go ahead and run. So that's just loaded information about those points onto those points. You see how they changed color, and now we're working with this output layer and not the original random points on lines. So now these points know what they're going to do. Now we need to go into analysis and Viewshed. Double click, and our analysis type is binary viewshed. Our output locations are the output layer we just created, and the digital elevation model is our same elevation model from before. We have some options here with how to combine multiple outputs, but we're going to keep the default, save to a temporary file, hit run, and expect this to take a little while. And 25 minutes later, the Viewshed analysis is complete. Go ahead and close that. Here is our trail, which is represented by 89 points. Now I did ask for 100 points, but I told it they couldn't be any less than 10 meters apart, so it dropped the number a bit. But this is our trail, and the lighter the color, the more times it can be seen from the trail. Zooming out a bit, we can see the wider viewshed here and the edge of that 5-kilometer radius. So all of this area, the tablelands, is not visible from the knife's edge because, well, there's a whole mountain in the way. But now we want to know which point has the best view. This can be the tricky bit. So we're going to go under View, Panels, Log Messages, and then over to Viewshed Info. And what you see here is a comma delimited data format. We have to copy the point ID all the way down here, and then Control-C. Now I'm going to go into Notepad, and if you're on a Mac, I'm not sure if this is the same. It might be. If it isn't, we're going to have to figure it out. You see how we have point ID, comma, visible pixels, comma, total pixels, and then all of that. I can go File, Save As, and I'm going to save that in GIS 300, week number 7. And see how it's only giving me one option there. That's a bit of a lie. So I'm going to call that visibility.csv, comma, separated values, CSV, and see if naming it that makes it so. In a CSV file, this is essentially the boundary between one column and the next column in a spreadsheet. So here we are, visibility as a CSV. I need to close this one first, so bye-bye. And then I can double-click on that, and there it is in Excel. So it knows, since it's a CSV, the comma means different row. Now I want to change this, no space. Spaces are terrible in names. So visible, and then total. So point ID, visible, total. Save. It's going to ask, do you want me to keep using CSV? I say, yes, I do. Thank you very much. Click out of that, and this is the tricky bit. So you do have to say don't save. You did just save, but it gets confused if you say save again. It asks you again, so don't save. That's fine. Now we can go ahead into week number 7. We're going to have to refresh this, and with that refresh done, we can go ahead and look for that, and we are looking for visibility.csv, which we can double click and bring in, And we can right click and open that attribute table. Take a look at our data. Yes, that looks good. Thank you very much. And now we can go ahead and take our output layer, right click, properties, and go to joins, just like we did with the bear and moose data and deer tool. Go ahead and add a join here, and we want to use the join layer visibility, the join field, point ID, target field, ID. And now OK, and OK. Now remember, these are unstable right after a join. You have to export to make a permanent feature. So right click, export, save feature as. Now I'm going to save this in week number 7, and that is visibility points area.shp. All else looks good. OK. OK, and there we go, new points layer. Now I'm going to right click on that, open its attribute table, and take a look here. So we have visibility, and then that visible 1. So that is the number of pixels. Each pixel is 1 meter square, or 1 square meter. And the visibility 1, that is the potentially visible area. That is the radius, 5,000 meters or 5 kilometers, less the area that's off the edge of that DEM data layer. So in some cases, we have a 5 kilometer radius. In other cases, well, that hits the edge of the map there, and there may be monsters out there, but there is no elevation data. But to the point, now we have the visible area from each one of those points, which we can right click, symbology, graduated, value. Now it's not doing the graduated option there because our visibility is text and not a number. So right click, open attribute table, visibility there, that's just text, so it needs to be a number. Let's see if we can fix it this way. So we want to create a new field. The output is vis area, and we'll call that, whole number. There's no fractions there. And that just equals visibility. So let's see if we can convert that. Preview looks good. Okay, same number, same everything. But now, if we go in here, let's toggle the editing here. Toggle editing, save the edits. Double click there. That was a sad noise, wasn't it? And then we want graduated. And now, haha, we have it. There's your lesson on data types. Now, classify. We have from smaller to greater visible area from each one. Okay, there you go. So you can see more, according to this model, from the ones that have a darker red. And why can we not see the most from the top of Baxter Peak? Go ahead and turn off that. And that, well, we missed the high point. So the high point looks like it's somewhere other than where our points fell. So that, if you really wanted to know what you could see from the very peak of Baxter Peak, then you would have to put a dot right on top of it, and that would almost definitely get you the best view. So that's one of the perils of having a crazy high-resolution data set where it's pretty easy to go off track. Might be a touch better with a 5-meter resolution. That'll give you a little more room for error. Right now my margin for error is 1 meter, and if I put it behind a rock, it's behind a rock and you can't see much. So picture this laying out a road in a national park. You want to have the best view from the park, so you can pick a couple of different potential routes and then see what the visibility is from each. Which one's going to give you the most bang for your buck? You can only build one road, so which one gets you the best view? Way back in the day before GIS, this was still a known concept, and when the carriage trails down in Acadia National Park were built for the Rockefellers who owned it at the time, the landscape architect was very careful to make sure that every time the road made a turn, you had what they called a vista, and that vista is some beautiful view. So as you're coming up on that turn, hopefully not getting distracted and driving off the edge of a cliff, but you'd have some nice view out over a pond or a ocean or something, waterfall, mountain, something. So you would have the biggest visual impact as you're going around that curve. On the other hand, if you're building a road and you don't want that road to be seen from somebody's house, you might be careful to make sure that the visibility, or the view shed from that house, does not line straight up with that road. So there's just a ton of uses for this, and I want you to do two things here. One, go ahead and replicate this analysis, use the 5-meter resolution data set. Don't mess up like I did and get the 1 meter. If you do, try again, it'll speed things up. And then pick one other spot of your choice. So 2 visibility analyses, one like mine, one of your own choice.